Assalamu alaikum and good morning, dear students. Students, you have already received 2 video lessons from the Unit 6 fractions, and this is the third part. So let us start learning the third part of Unit 6 fractions. In this lesson, we'll learn how to add and subtract fractions. Firstly, we will see how to add and subtract like fractions. Now, if you remember, like fractions are the fractions with same denominators that you can see here in the example. Let us see this example of pizza slices. So what do when we add 2/6 of a pizza with 1/6 of a pizza? We can simply add the slices 2 plus 1, which gives us 3/6 of the pizza. In another example of parts shaded in a rectangle, you can see 5/6 parts of the rectangle and 2/6 parts of the rectangle are being subtracted. So what do we get? We get 3/6 part of the rectangle. What you can understand from both these example, students? Adding or subtracting like fractions is very simple because here we only add or subtract the numerators while keeping the denominators same. Let us solve some examples, students. Here we have to add a pair of like fractions 11/21 and 6/21. We remember that we have to only add the numerators while we keep the denominators same. So here we'll be just adding 11 and 6. So what do we get? We get 17 as the sum in the numerator and the denominator remains same. Another example of subtract. Here we'll have to subtract 12/15 minus 5/15. So when we do that, we should remember that we have to only subtract the numerators while we keep the denominators same. So the answer would be 12 minus 5 gets us the numerator 7, and the fraction will be 7/15 while we keep the denominator same. So my dear students, you can see that adding and subtracting like fractions is quite simple. Now we will study how to add and subtract unlike fractions. If you recall, students, unlike fractions are fractions with different denominators. And we have seen in our video lesson today that adding and subtracting like fractions is very easy. And you have also learned in your previous video lessons how to convert unlike to like fractions. So whenever we are given to add and subtract unlike fractions, the first thing we'll do is we'll convert them to like fractions. Now let us recall how to convert unlike to like fractions. Firstly, we'll find LCM of the denominators. Then we'll find equivalent fractions with LCM as denominator, so that both the fractions have common same denominator. And then the new equivalent fractions that we obtain become like fractions because their denominators are same. And now finally we can add or subtract the given like fractions. Now let us solve our first question. Students, here we can see a pair of unlike fractions, isn't it? So let us just try to first do the first step, which is finding the LCM of the denominators. You see here 5 and 6 are two consecutive numbers that comes after one another. For such numbers, the LCM is their product. So we multiply 5 and 6 and we get the LCM as 30. After we do that, the second step is to write the equivalent fractions with denominators equal to LCM. Okay, so we have to find their equivalent fractions. Let us first see this case. Okay, we have 3/5 and we know that we should get 30 as the denominator. So what do we multiply to 5 to make it 30? The answer would be 6. So anything that you multiply to the denominator, same number should be multiplied to the numerator. Hence, we multiply 6 to both denominator and numerator, getting its equivalent fraction as 18/30. Secondly, for the next fraction 1/6, we see what shall we multiply to 6 to make it 30. Okay, because our concern is to make the denominator equal to its LCM by finding its equivalent fraction. So we multiply 6 with 5 and same has to be multiplied to the numerator, 1 into 5, getting us an equivalent fraction of 5/30. Now what has happened, students? 3 by 5 has turned to 18 by 30, 1 by 6 has turned to 5 by 30, getting us a pair of like fractions. And we know adding like fractions is very simple, because here we have to simply add both the numerators while keeping the denominators same. So now we have added 18 plus 5, getting us the numerator 23. Please do not add the denominators. Never do that mistake. Denominators remain same for like fractions. So 23 by 30 is the product. Here, students, I want to say you one thing, that if at all your answer has any common factor for numerator and denominator, then it has to be reduced to the lowest form. We will see some examples in our video ahead. Now let us see an example of subtraction. You can see a pair of unlike fractions and we have to subtract them. Of course, our first step will be to take the LCM of the denominators. And here we can see that 4 and 8 do have some common factors. So let us see how to find their LCM. You can divide it with their common prime factors until you get 1. So now the product of these prime factors will be its LCM. Hence the LCM of 4 and 8 is 8. 2 into 2 into 2, which gives us 8. The second step is to write their equivalent fractions with LCM as the denominator. So now what do we have? For the first fraction, we already have 8 as the denominator. So even if you directly keep it as 7 by 8, it is absolutely correct. No need to mention here into 1. That's correct. But for 3 by 4, we have to convert 4 into 8. So how do we do that? 4 has to be multiplied with 2 to get us 8. And the same number has to be multiplied to the numerator. So 3 2s will be 6. The equivalent fraction of 3 by 4 is 6 by 8. Now we can simply subtract both the numerators while keeping the denominators same, and we get the answer as 1 by 8. There's another example over here of adding fractions with unlike denominators. That means they are different denominator, unlike fractions. So we have 3 by 4 plus 3 by 2. Now there is a common error that students do here. That's why I've taken this example. What do they feel is they find the numerator same, so they keep the numerator same and they add the denominator, and they make a big mistake. So that is not the case. What we have to do is, the moment we see different denominators, we should realize that they are unlike fractions and we need to take LCM of the denominators so that we convert them into their equivalent fractions. Hence we find the LCM of 5 and 2. They do not have any common factor, students. They don't go in any common table together. For such numbers, the LCM will be their product. So we multiply 2 5s are 10 is the LCM. Now we need to individually see how to convert each fraction into its equivalent. Let us just first see for 3 by 5. Okay, 5 has to be converted into 10. So we multiply 5 with 2, and 3 also has to be multiplied with 2. So 3 by 5 turns to 6 by 10. Similarly, 3 by 2 also, we have to multiply 2 to a number so that we get 10. That will be 2 into 5 gives us 10, and same number has to be multiplied to 3 as well. So 3 5s gives us 15. Now what has happened is 3 by 5 and 3 by 2 has turned into their equivalents, 6 by 10 and 15 by 10, also making them as like fractions. And we know that when we are adding or subtracting like fractions, we can simply add their numerators. So 21 is the numerator and denominator will remain 10. Now what with this, children? I was saying you that if at all you have an improper fraction as the final answer, then it is better that you convert it into a mixed fraction as the final result. Okay, so there is a remember point here that you should actually remember. The answer should be in lowest form or mixed number. Okay, lowest form is when both numerator and denominator could be divided by any common factor. And mixed number is when a fraction in the answer is improper. So here, because 21 is greater than 10, we have to convert it into its mixed fraction. You remember how to convert it. We divide. While we put the quotient here as the whole number, the remainder in the numerator and the denominator remains the same. Okay, students. Now here you see an example. Just have a look over here. This is from your textbook exercise 60, page number 88. First question is when you have to add 1 by 9 and 2 by 3. Of course, we have to find the LCM. So when we find the LCM of 9 and 3, you have to do some rough working over here. You get the LCM as 9. So 1 by 9 will remain same as the denominator here is already 9. But for 2 by 3, 3 has to be multiplied with 3. And the same number has to be multiplied with 2 so that we get it equivalent. And then we add the numerators to get the answer as 7 by 9. So likewise, I have done here 2 more examples which you can pause the video and see and understand so that you have a better understanding of the concept. Okay, I have done 3 bits for you from the textbook. Now let us move towards the second question, students. Please read the question carefully. They say solve, give your answer in the lowest term or as a mixed number. So that is what I was talking about in the previous question. Now let us see. Here we have the first question, bit number A, 1 by 6 plus 1 by 3. Definitely they are unlike fractions, so we have to find their LCM. LCM of 6 and 3 would be 6. And now finally we have to convert to their equivalents with LCM as the denominator. So 1 by 6 we won't have to do anything because LCM is already there in the denominator, but for 1 by 3 we will have to do some multiplication. 3 should be multiplied with 2 to make it 6, so 1 should also be multiplied with 2. 1 by 6 plus 2 by 6 gives us 3 by 6. Here students, take a special care that when you find an answer which can be further reduced into lowest form, you have to do some working. Now what do I mean by that? Please observe over here, we have already learned about lowest form. The numerator and denominator, both of them have 3 as their common factor. So we are going to divide them by 3, okay? And then we get the answer as 1 by 2. Now 1 and 2 does not have any other factor except for 1 only, any common factor. So we can stop over here declaring it as the lowest form. Okay students, I have another bit over here, bit number E, 8 by 9 plus 5 by 12, which I will try to do in the video here and make you understand how you are also supposed to do in your notebook. Now let us do this example. To add unlike fractions, we have to first take LCM of the denominators. So let us find the LCM of 9 and 12. We have to divide it by any common factor. Okay, any common prime factor. If you see, 3 in 3's table, both 9 and 12 goes. So we can divide by 3, giving us the answer as 3 3s are 9 and 3 4s are 12. Okay, when we come to this step, students, we realize that both 3 and 4 do not have anything in common, right, except for 1. So we can stop here and we can say that the LCM is 3 into 3 into 4, which is 36. Now the next step is to find equivalent fractions with LCM as denominators. That means we have to find equivalent fractions of both 8 by 9 and 5 by 12 such that the denominator becomes 36. So what should I multiply to 9 to make it 36? I have to look at the denominator, right? The answer would be 9 4s are 36. The same number I have to multiply to the numerator also. So it gives us the equivalent fraction as 32 by 36. I am doing this sum particularly so that you have an example of how you have to solve while you do some questions in your notebook. Similarly, we have to check for the other one to get its equivalent fraction with denominator as 36. So 12 3s will give me 36. Same, if I multiply in the numerator, we'll get the answer as 5 3s are 15 by 12 3s are 36. So that will be 15 by 36. Okay, so when we turn them into like fractions, we can simply add the numerators while keeping the denominators same. So here in a single step, I am going to write down 32 plus 15 in the numerator, and I will take whole divided by 36 because anyway we keep the denominator same and we add the numerator only. So now when we add 32 plus 15, students, we get the answer as 47. 47 by 36 is our fraction that we got. But whenever we get an answer, children, you have to check 2 things. First thing is whether it is in the lowest term. Yes, it is in the lowest term because 47 and 36 do not have any common factor. Second thing that you have to check is you have to see whether it's an improper fraction. Okay, because we have to reduce the answer. If it is, yes, it is an improper fraction, so we should reduce it into a mixed number, into a mixed fraction. So how do we do that? I'm doing here in the rough work side. Please have a look. What we do is we divide 47 by 36. It's quite simple. We need not know 36 table. We can just make out that 36 is very close to 47, so it will go one time only. 36 ones are 36. Now when we subtract, what do we get? We get 11 as our remainder. So how do we write a mixed number? I will write it right here itself. 1, the quotient, will come as the whole number. The remainder will come in the numerator and the divisor will remain the denominator. So our final answer will be 111 by 36. This is our final answer, students. Moving ahead to exercise 6E, here you have to add some mixed numbers also. Let us see an example. 5 plus 3 1 by 2. So 5 is a whole number. A whole number can be written as a fraction by keeping the denominator as 1. So I've written 5 as 5 by 1 so that it looks like a fraction to me. And now what about 3 1 by 2? There's nothing to fear about it. When you have mixed numbers in your question, convert them to their improper fractions. So how do? We multiply 2 3s are 6, 6 plus 1, 7 becomes the numerator and denominator remains same, so 7 by 2. Now it is the same case. It is like adding two unlike fractions. We know that when we have unlike fractions, we should take their LCM. LCM of 1 and 2 is 2 only. So this one I have to multiply 2 and 5 should also be multiplied with 2, getting its equivalent fraction as 10 by 2. Whereas 7 by 2 remains as it is. Now when we add the numerators, 10 plus 7 gives us 17 by 2. As I've shown you in the previous example, we cannot leave the answers as improper fractions. We have to give the answer in their simplest form by either converting the improper fraction to mixed fraction, or if there is any lowest form possible, then writing that. But here, because 17 and 2 do not have anything in common, we will have to divide. So when you divide and you find out the answer, you're getting the mixed number as 8 1 by 2. Let us see one more example, bit number D. Here you see a set of two mixed numbers. So one after another, you're going to convert them into their improper fractions. How do we do that? We multiply 4 into 1, 4, and then we add 3. Gives us 7. 4 plus 3, 7 by 4. Similarly, 3 2s are 6, 6 plus 2, 8. 8 by 3. Now, the case is of adding two unlike fractions. So firstly, we'll find their LCM of the denominators. So the LCM of 3 and 4 will be 12. And then we are going to write their equivalent fractions such that the denominators become 12. We have seen plenty of examples of that sort. And then we add. We get 21 plus 32 as 53 by 12. What do you see here, students? It is an improper fraction which can be converted to a mixed number. So it's been converted as 4 5 by 12. Now we have an example of subtracting two unlike fractions from exercise 6F. You can view it on your screen. There are two unlike fractions. So first of all, we will have to find its denominators LCM. So we'll find the LCM of 2 and 3, which gives us 6. Okay, and then converting them to their equivalent so that the denominators remain same. Okay, now we get 3 by 6 minus 2 by 6. That gives us the answer as 1 by 6. You can see another example over here also. The LCM of 6 and 4 was to be found. Once you find the LCM, you have to just convert them into their equivalent fractions. And then when the denominators become same, subtract the numerators. You can pause the video and see the examples carefully. This is about subtracting mixed numbers. It's just same as you have done for addition also. We have to first convert the mixed numbers into their improper fractions and then subtract them. Here the case was quite simple because they were already having same denominators. So we did not take their LCM further. We'll only directly subtract the numerators. 23 minus 9 will give us 14. 14 by 6. But we won't stop over here, students. Please carefully notice here, 14 and 6 can be divided by 2 and reduced further. That is very, very important. So we divide it by 2 and then we get 7 by 3. Even here we won't have to stop because 7 and 3, 7 being greater than the denominator, it's an improper fraction. It has to be converted into a mixed number. So very quickly you can divide and then get the mixed number. Please see another example over here. You can pause the video and carefully see the example of how to do subtraction of mixed numbers. The same exercise also has some word problems which are very simple. The main thing, students, you have to decide whether to add or subtract. Now when you have practiced many addition and subtraction questions, the word problems should become very, very easy for you. See, second question, bit number B. Ankana did 3 by 8 of her homework on Saturday and 1 by 4 of her homework on Sunday. How much of the work did she do over the weekend? So basically we have to combine both of our work on both the days. Combination is addition, students. So we have to add 3 by 8 and 1 by 4. When we notice the denominators are different, so we have to take their LCM. LCM of 4 and 8 is 8, and then convert them into their equivalent fractions. We get them as 3 by 8 plus 2 by 8. At the numerators, we can say that she did 5 by 8 of her homework on the weekend. A very simple question. Let us see the next one. If 3 2 by 3 meters is cut from a ribbon which is 5 1 by 2 meters long, how much ribbon is left? Okay, when they ask how much ribbon is remaining or left, it is definitely about the subtraction, because here you can even make out from the word cut. The ribbon was originally 5 1 by 2 meters long, and from which a part of it is cut. So it is subtracted, you can assume. And that's why we'll have to subtract 5 1 by 2 minus 3 2 by 3. They both are mixed numbers, students. We have seen examples like that. Let us first convert them into improper fractions. So 2 5s are 10, 10 plus 1, 11 by 2. 3 3s are 9, 9 plus 2, 11 by 3. What do we do over here? Because the denominators are different, we take the LCM. LCM of 2 and 3 will be 2 3s are 6. And then finally, we convert them into their equivalent fraction, making them 33 by 6 and 22 by 6. When you subtract them, students, you get 11 by 6. But as I told you, the final answers should not be improper fractions. That's why we convert it into a mixed number, getting us the answer as 1 5 by 6 meters of ribbon is left. A recipe needs 2 by 5 cup of milk and 1 by 3 cup of cream. How much more milk than cream is required? So the main operation idea we get from this statement. Okay, because here they're asking us to compare the quantity of milk and cream. How much more or how much less means comparison. Comparison is finding differences, which definitely means subtraction. That's why here we subtract 2 by 5 and 1 by 3. We take the LCM of 5 and 3, which gives us 15. Okay, and then we convert them into their equivalents. When we convert them to their equivalents with denominators as 15, we make them like fractions, and we can definitely make out which is greater. Definitely milk is greater over here. We subtract them. 6 by 15 minus 5 by 15 gives us 1 by 15. So we can give the answer in the form of statement that 1 by 15 cup of milk is required more than that of cream. With this, we have come to the end of the video lesson. Thank you, students, for watching the video.